Assalamualaikum warahmatullahi wabarakatuh. Good morning, good evening, and good afternoon. My name is Vicky Adania from Universitas Airlangga. I'm working with Dr. Andika Wisnujati, Dr. Putri Rahmawati, Dr. Shamsul Ma'arif, and Dr. Nur Farizan Munajat for this project titled Plastic Waste Pyrolysis Reactors with Integration of Rocket Stove and Advanced Heat Transfer System and Analysis of its Design. So for the next 10 minutes, I'm going to talk about introductions, the background why we would like to do this project, and the related work, methods in this project, results and discussions, and the last one is conclusions. Seconds, I need to change this slide. Okay, so actually the background why we need to conduct this study is that the growing accumulation of plastic waste, especially in the household waste, that this plastic waste here has been so much, that's a huge amount that produced by the household. And we need to make it more beneficial. Therefore, we would like to propose one method of the plastic waste management by proposing a pyrolysis. It's a thermochemical process that decomposes organic materials in the absence of oxygens, offers a promising method for converting plastic waste into valuable products, such as a bio oil, syngas, and car. However, here there's a problem. Once when we are going to propose the reactor tube for the pyrolysis, there is a leakage in the joint between the cover and the tube in the pyrolysis reactor. As you see here, process flow diagram of pyrolysis. Usually, when we have the base materials, we are going to conduct initial treatment, drying, size reduction, sorting, and cleaning. Okay? And then it's going to be followed by, so for example, once when we have the plastic waste, we need to dry it first, and then we need to wrap and to not only, let's say, to vacuum the oxygen, so we will reduce the size of the plastic waste. And also here we need to have a sorting and cleaning. And then after that, we are going to conduct like a pyrolysis process in which there is a process of heat and mass transfer and chemical reactions. Hopefully, after the post process of pyrolysis, we will produce a bio-oil gas and biochar. Okay? So these process flow diagram pyrolysis actually has been proposed by Poshnov 2022. So based on Rahman 2018, Lee et al. 2020, and Chan et al. 2019, they all agree that optimizing pyrolysis process for different types of feedstocks here include biomass, agricultural residues, and plastic waste. Therefore, once when we have a problem with the plastic waste, we would like to propose here by, let's say, by offering let's say, reactor tube for the pyrolysis process. This is a design of pyrolysis reactor for production of bio-oil. Usually, the large amount of hydrocarbons seen in the pyrolysis results in the main cause. So that would be one of the challenges if we apply pyrolysis reactor to manage the plastic waste. Therefore, we would like to propose a pyrolysis reactor from our work. We look at this, let's say this design. It's a pipe number 1 here, pipe, coil, upper cap, reactor tube inside number 4. This is a tube inside, out pipe, condenser tube, and so on and so on. Pyrolysis reactors are designed with a vertical cylindrical cross-section shell. The decision to keep the head serving as the reactor and cap flat was made to minimize manufacturing expenses, facilitate maintenance, and has heat transmission capabilities. Here, we also, in our methods to propose the functions that this design is much better than before, our method here is implementing the simulation, pyrolysis reactor tube by Autodesk Inventor 2016. If you look at the top here, start, gather design, create 3D model, set up a finite element model, and then we perform material assignment and run initial simulation. So we conducted a simulation called Autodesk Inventor 2016. So once when we finished the simulations here, the stress analysis here provides a crucial insights into mechanical performance and structural integrity of the reactor under operational conditions. These high stress areas are found around discontinuities such as weld joints, bends, and points of attachment for other components. So as I said before here, usually we had a challenge in terms of the pyrolysis reactor tube when there is a leakage between the tube and also the cover of the reactor. Once when we had the simulations, actually we involved several parameters. The parameters include the mass density, yield strength, ultimate tensile strength, Young's modulus, Poisson's ratio, shear modulus, mass density, yield strength also. So these are the parameters that we involved for the simulations. And these results also, the current step involves determining the reference positions of the support constraints and loads in the design that has been constructed, including the stress analysis and reactor tube pyrolysis. So these are the results, stress analysis and reactor tube pyrolysis 2. There is a minimum and also the maximum. Therefore, here we can see that these placement locations in which area. Okay, so these are the results. If you look at the first one here, found means a stress reactor tube. So the problem is that there is a leakage here usually. Okay, so between the tube and the cover here, there is a leakage. Once when we are doing our simulations, indeed that this placement of reactor tube is found in the red area. If you see in the center here. So displacement of reactor tube here, based on the simulation, indicates that the design undergoes deformation when exposed to external force. So if you look at this one, if you look at the picture, and this red indicates displacement of reactor tube. On the right side here, the picture shows the safety factor in a reactor tube. The safety factor ensures the structural integrity and safe operations of the reactor under various conditions. Therefore, as our conclusions here, the analysis highlighted opportunities for optimizing the reactor tube design to reduce stress concentrations and enhance durability. Possible design modifications include increasing the wall thickness in high stress areas, using smoother transitions at bands and joints to minimize stress rises, and incorporating thermal insulation or cooling mechanisms to manage temperature gradients more effectively. By implementing these changes, we hope that it can reduce the likelihood of the mechanical failure and extend the reactor's operational life. So we hope that these contributions will be given by the design that we proposed. Thank you. Hopefully that this small project will give some benefits and will give some highlight, let's say some contributions to the design of the pyrolysis reactor tube. Also can be implemented for managing the plastic waste, especially generated from the household. Thank you once again for listening our presentations. Terima kasih. UMY ada masyarakat berdaya. Assalamualaikum warahmatullahi wabarakatuh.